Good morning, students. So, in the last class, we are discussing about the different types of problems based on nodal analysis, mesh analysis, and also we discuss a problem based on superposition theorem. So, total we have total three theorems in BWE. So, that is the superposition theorem, Thevenin's theorem, and Norton's theorem. So, in the last class, we are already discussed about the superposition theorem, and in today's class, we are discussing about the one more theorem, that is Thevenin's theorem. Thevenin's theorem. Okay, so by using this also we can find the current through different elements or at any particular source. So what is the procedure and how we can apply theorems and how we can find the current through particular element, we will see in this theorem. So first let us consider any one of the circuit. So by taking an example, we'll clearly understand. Suppose a given circuit is like this. So this is the having a resistance and one more, and this is the T network having three different resistors. And suppose here I am giving one more voltage source. So it is also one more voltage source. Suppose this is the resistor R1 and resistor R2, resistor R3, and this is the voltage source 1 and this is the voltage source 2. So suppose this is the one of the circuit. So for this circuit in the experiment they are already given some values, but I am taking just an example here first. So it is having three different resistors R1, R2, and R3, and different voltage sources V1 and V2. Suppose we need to find the current through these particular R3 resistance. Suppose if they are asking to find the current through resistor R3. So that is by using Thevenin's theorem. Find the current through resistor R3 by using Thevenin's theorem. So for these particular resistance R3, suppose if we are applying the nodal analysis, then also we get one answer, and by applying mesh also we get the same answer. By applying superposition theorem also we get the same answer. By applying Thevenin's theorem is also we get the same answer. By applying Norton's theorem also we get the same answer. But the procedure is different for nodal, mesh, superposition, Thevenin's and Norton's theorem. So suppose in the examination, if they are asking to find by applying mesh, then we follow mesh only. If they are asking to nodal, then we follow nodal. Or if they are asking any particular theorem, so then we follow that particular theorem only. The procedure is different for all these, but the final answer is same for nodal, mesh, superposition, Thevenin's and Norton's theorem. So here in the previous class, class, we are applying nodal analysis, mesh analysis, and superposition theorem also. So in this class, we are applying Thevenin's theorem procedure. So to find the current through this particular resistance R3 by using Thevenin's theorem. So we see, so to find the current through this particular resistance R3 by using Thevenin's theorem. So for that, we have to find the four different values. So to find, first we need to find the current. So what is the current? And V Thevenins, and next R Thevenins, and finally by drawing equivalent circuit. And we need to find the IL. So that is a total current, that is the current flowing through resistor R3. So first, how we can find the current I? So to find the current I, so where we need to find the current, so that branch should be removed. Suppose if we need to find the current through resistor R3, suppose resistor R3 is they are giving some value. So first we just remove R3. So then the circuit will become, so this is the R1 and this is the R2 and this is the source 1 and this is source 2. So suppose this is the point A, point B. So we need to find the in AB. So here this is the point A and this is the point B. So we need to remove this R3. So here we need to find the value of Thevenin's. So this is the R1 and this is the R2. So by applying a nodal or mesh analysis, we just find the current through these particular element, and then we need to find the Thevenin's. So after finding the Thevenin's, how we can find Thevenin's? So to find the Thevenin's, we just redraw the circuit. So but that circuit in place of voltage source, that should be short circuited, and in place of current source, that should be open circuited. So we just take one example, so then you will clearly understand how we can apply nodal or mesh analysis, and how can we find all this, that is current, Thevenin's, Thevenin's, and how can we draw the equivalent circuit, and how can we find the current total finally, so that we clearly understand by taking an example. So see here, so I am taking one example. So this is the resistor 1, 2, and this is the one more resistance. It is a T network. Again we are taking one source, and this is the source 2. So we are taking some different values for these circuits. Suppose this is the 4 ohm resistance, and here plus minus, and this voltage source is suppose 20 volts, and in the middle this is the 16 ohm resistance, and this is the 24 ohm resistance, so positive and negative, and this is the second source. Suppose this second source is the 30 volts. Suppose if they are given a circuit like this, and here the question is find the current through 16 ohm resistance. Find the current through 16 ohm resistance. Suppose if they are asking to find the current through 16 ohm resistance by applying Thevenin's theorem. So how we can solve by applying superposition theorem to find the current through 16 ohm resistance. So our first step, so to by applying superposition theorem we can find here. So in superposition theorem our first step is to find the current. So for that, first we just remove 16 ohm resistance. Remove 16 ohm resistance. So where we need to find, suppose in the question we need to find the current through 16 ohm resistance. So we just remove that 16 ohm resistance. So where we need to find, that should be removed in step first. So after removing the 16 ohm resistance, you can redraw the circuit. That is this is the 4 ohm resistance, and this is the 24 ohm resistance. So here this is the voltage source 1, and this is the voltage source 2. So just redraw the values also. So this is the voltage source 1. Voltage source 1 is 20 volts, and here this is the 4 ohm resistance, 24 ohm resistance, and the second source value is 30 volts. Suppose we are taking some points here. So AB. So we need to find the current through branch AB, that is 16 ohm resistance. So this is the point A, and this is the point B. So we just remove this one. So now apply nodal analysis or mesh analysis and find the current. Suppose I am taking a mesh. Suppose this is the direction of current. So the current direction should be assumed either in clockwise direction or anti-clockwise direction, whatever it may be. So I am taking in a clockwise direction. So now apply a mesh analysis. Already we discussed in the last class how we can apply the nodal analysis and how we can apply the mesh analysis. Suppose current is flowing in this direction. So already we discussed about the sign conversion also in the last class. So by applying nodal analysis we can write the equation. So the equation is 4i1 next plus 24i1. There is only one loop. 4i1 plus 24i1 plus 30 minus 20 is equal to 0. So total 4i1 plus 24i1, that is 28i1 plus 10 equals to 0. Therefore I1 is equals to minus 10 by 28. By using calculation, what is the value? Minus 10 by 28. So that equal to minus 0.3571. So that is the current minus 0.3571. So after finding the current, we need to find the value of Vthevens. So we need to find the value of Vthevens. So how can we find Vthevens? So to find the Vthevens, so there are number of ways to find the Vthevenin by applying voltage division rule or some other. So I am going to proceed the one of the method. So that is, we need to find the Thevenin's voltage from point A to B. So for that, you just redraw the circuit from point A to point B, only from point A to point B in any direction. So suppose and rather, so this is the point A, and next 4 ohm resistance again, so 20 volts voltage source, and this is the point B. So here, what is the value of this resistance? This is the 4 ohm resistance, and this is the 20 volts. So this is the minus plus plus minus. So here also you apply the same mesh analysis. So then we get Vthevens. So here Vthevens is equals to minus 4. So here this is the 4 ohm resistance that is linked with loop 1. So there is only one loop. So what is the current? What is the current flowing through 4 ohm resistance? Already we are getting current I is equals to minus 0.3571. So minus 0.3571 and plus 20 is equals to 0. So no, there is no equal to. Already we need to find the Vthevens. Okay. So Vthevenin is equals to minus 4 of current value is minus 0.3571 plus the voltage source value is 20. So therefore, what is this value? By using calc, minus 4 of minus 0.3571 plus 20, and its value is equals to 21.428. So that is the Vthevenin. So we just find the value of current, that is minus 0.3571, as well as we need to find the current voltage, that is also we are finding, that is Vthevenin is equals to 21.428. So in the next step, we just find the Rthevens. So in the next step, we need to find the value of Rthevenin. So what is the total resistance or equivalent resistance? So to find the equivalent resistance, so we just redraw the circuit. So we just redraw the circuit. After removing, we draw the one circuit. So you just redraw the same circuit. The only change is, so in place of voltage source, it should be short circuited. Suppose if there is any current source, that should be open circuited. So just redraw the same circuit like this. This is only, but the only change is in place of voltage source, that should be short circuited. So that can be drawn. That is, so this is the 4 ohm resistance. Again, this is the 24 ohm resistance. So here one voltage source is there. So that should be short circuited. So again, this is the source 2, that is also short circuited. So here this is the 4 ohm resistance and this is the 24 ohm resistance. So here point A and this is the point B. So here we need to find the value of Rthevens. So see here, so here the two resistances. Here there are only two resistance. One is the 4 ohm and second one is the 24 ohm. So here the 4 ohm, 24 ohm both are connected in parallel. So already we discussed about the series and parallel circuits in the previous class. So when two, here these two are in parallel. So when two resistors are connected in parallel, so then what is the formula to find the R equivalent? So when two resistors are connected in parallel, then 1 by R equivalent is equals to 1 by R1 plus 1 by R2. So here we need to find the value of R equivalent. So R equivalent equal to, how we can find R equivalent equals to R1 into R2 by R1 plus R2. So by using this formula we can find, so that is R Thevenin is equals to R1 into R2 means 4 into 24. 4 into 24 by R1 plus R2. 4 plus 24 that equal to, what is the value of 4 into 24 by 4 plus 24? By using calc, 4 into 24 by 4 plus 24, and its value is equals to 3.428. So that equals to R Thevenin is equals to 3.428. So this is the third step, that is we are already finding the R Thevenin. So after this we just draw the equivalent circuit. We just draw the equivalent circuit. So to draw the equivalent circuit, just once again remember the statement of Thevenin's theorem. So what is the statement of Thevenin's theorem? So the Thevenin's theorem states that in any linear bilateral network, it consisting of several resistances and voltage sources that can be replaced by a single voltage source in series with a single resistance connected across the load. So here the circuit consisting of any number of voltage sources or resistances. So all these are replaced. All these are replaced by a single voltage source. A single voltage source is in series with a single resistance and connected across the load. So this is the equivalent circuit of a Thevenin's theorem. For any problem by applying Thevenin's theorem, so we can draw the equivalent circuit in the same way. So the given circuit consisting of any number of voltage sources or resistances that can be replaced by a single voltage source, that is V Thevenin's, is connected in series with a single resistance, that is R Thevenin's, and that combination is connected across a load resistance, that is RL. So this is the equivalent circuit. So you just substitute the values of VThevenin. So what is the value we get VThevenin? So VThevenin here, VThevenin is equals to 21.428. VThevenin is equals to 21.428. Then what about R Thevenin? R Thevenin we get 3.428. Then what about RL? RL is nothing but where we need to find the current, that is RL. So in the question, find the current through 16 ohm resistance. That means the 16 is the load resistance. So it is the where we need to find, that should be taken as a load resistance. RL is equals to 16 ohm resistance. So here VThevenin is equals to 21.428 and RThevenin is equals to 3.428 and load resistance is equal to 16 ohm resistance. So now we need to find the total current, that is IL. So what is the formula to find the IL? IL is equals to V Thevenin's by R Thevenin's plus RL. So this is the formula to find the total current. So substitute here, therefore IL is equals to V Thevenin's. What is the value of V Thevenin's we get? So 21.428 by R Thevenin's. R Thevenin's is the 3.428 plus RL. RL is the 16 ohm resistance. So what is the value? Calcium. 21.428 by 3.428 plus 16. 21.428 plus 3.428 plus 6. Okay. So its value is equals to 1.102. So that is the current flowing through 16 ohm resistance. So coming to the question. So this is the question. For this circuit, we need to find the current through 16 ohm resistance. So the current through 16 ohm resistance is equals to, we get 1.102. So this is solved by using Thevenin's theorem. Suppose if we check, so in the last class we are applying superposition theorem. Before that class we are applying nodal analysis and mesh analysis for the same circuit. For the this circuit is there. What is the question is that circuit? For this circuit, you just may apply nodal analysis or mesh analysis or superposition theorem. You may get the same answer. Once if you have any doubt, you check once. So by applying nodal or mesh or superposition or Thevenin's or Norton's, any of these we get the same answer, but the procedure is different. So this is the Thevenin's theorem. So once again See here. So here this is a question. So for this we need to find the current through 16 ohm resistance. So to find the current through 16 ohm resistance by applying Thevenin's theorem, we just follow some procedures. So first we need to find the current, and then after we need to find the V Thevenins and then R Thevenins, and finally we just draw the equivalent circuit and find the total current. So first to find the current, so where we need to find, suppose if they are asking to in the question they are asking find the current through 16 ohm resistance. So in the first step we just remove the 16 ohm resistance and find the current to that particular circuit by applying nodal or mesh. Suppose here I am applying mesh analysis, just assume the current direction either in clockwise or anti-clockwise. So here I am taking the current in clockwise direction, and by applying mesh we get the current I is equals to minus 0.3571. So next we need to find the value of VThevenin. So to find the VThevenin by applying voltage division rule also useful, but here I'm taking one more different procedure. So you just draw the from point A to point B. Again you just redraw the circuit from point A to point B. So either in this direction or in this direction, in any direction you can draw. So I am taking suppose this. So here also by applying mesh we get the VThevenin is equals to 21.428. So next we need to find the value of RThevenin. So to find the value of RThevenin, first draw the circuit. So which is same as like this. So after removing we get one circuit. So you just redraw the same circuit, but the only change is in place of voltage source it should be short circuited. Suppose if there any current source is there, so in that case that is a open circuited. So remaining will be same. So see here by drawing this circuit, here 2 ohm resistance, one is the 4 ohm resistance and second one is the 24 ohm resistance. So here both 4 ohm resistance and 24 ohm resistance are connected in parallel. So when when two when two resistors are connected in parallel, so then how we can find the R equivalent? That is 1 by R equivalent equals to 1 by R1 plus 1 by R2. So here we need to find R equivalent. Therefore R equivalent is equals to R1 into R2 by R1 plus R2. So by substituting this value we get 3.48, and after finally we just draw the equivalent circuit. So how can we draw the equivalent circuit? That is according to the statement of Thevenin's theorem. So what is the statement of Thevenin's theorem? So in any linear bilateral network consisting of several resistances and voltage sources that can be replaced by a single voltage source which is in series with a single resistance, and that should be connected across a load resistance, and you just give the values. What is the VThevenin, RThevenin we are already getting, and RL load resistance. Load resistance is the, so where we need to find, that is should be taken as a load resistance. So in the question we need to find the current through 16 ohm resistance, so that is RL. So after drawing the equivalent circuit we just find the total current IL. So that is find by using a formula VThevenin by RThevenin plus RL. So by substituting that value we get the answer is 1.102. So this is the Thevenin's theorem. Okay, it is clear. So next we are going to solve one more problem based on Norton's theorem. So this is the Thevenin's theorem, and next we are going to solve one problem based on Norton's theorem. Okay, so just I'm taking one circuit again, so then only will clearly understand what is the procedure to apply to find the current and how we can apply the Norton's theorem procedure. You just see one circuit. So here before that we just see the statement of Norton's theorem. So the Norton's theorem states that in any linear bilateral network consisting of number of sources and elements that can be replaced by a single current source is in parallel with a single resistance connected across the load. So almost the statement of Thevenin's and Norton's is same. The only change is in Thevenin's theorem the volt that is replaced by a voltage source is in series with a single resistance. But here in Norton's theorem, so all the elements can be replaced by a current source is in parallel. In Thevenin's theorem, that is in series with resistance, but in Norton's theorem, here that is in parallel with the current source. So that is the only change. So by taking an example, you will clearly understand what is the difference between Thevenin's theorem and Norton's theorem, and what is the procedure, how we can apply the Thevenin's and Norton's theorem. You will clearly understand by taking an example. So suppose I'm taking one more example here. So suppose this is the resistor 1, and this is the one more resistor here, and suppose this is the one voltage source plus minus. So this is the middle, it is the one more resistance, and here also one more resistance, and here one voltage source. Okay, this is the one of the circuit. We are assuming one circuit, so we are assuming some values also for this circuit. So suppose this resistance is 10 ohms, and in the middle this is the 5 ohms. So here this is the 0.1 ohm. This voltage source is suppose 2 volts, and coming right side this is the 20 ohms, and this is the 0.2 ohms. Here one more voltage source is there. You just assume some values 4 volts also. So in the previous case, and here suppose the question is suppose if they are asking to find the current through 5 ohm resistance by applying Norton's theorem. Find the current through 5 ohm resistance by applying Norton's theorem. Find the current through 5 ohm resistance by applying Norton's theorem. So in the previous class, that is in Thevenin's theorem, so where we need to find, that should be removed in the first case. Suppose in the previous case we need to find the, so this is the Thevenin's theorem. Okay, so here the Thevenin's theorem, we need to find the current through 16 ohm resistance. So we just remove the 16 ohm resistance first. That is the procedure for Thevenin's theorem. But in Norton's theorem, so here we need to find the current through 5 ohm resistance. So where we need to find the current, that particular element, that particular resistance should be short circuited here first. So here first, so here also to find the total current by using Norton's theorem, we just find the value of first Norton's current. So we just find the value of Norton's current, and in the second step we just find the value of Norton's resistance, that is the total resistance in that particular circuit. And after finding the current and resistance, you just draw the equivalent circuit, and then find the value of total current IL or load current IL. So this is the procedure for Norton's theorem. First we just find the Norton's current, Norton's resistance, and equivalent circuit, and fourth step lo finally we get the total current, that is IL, by applying formula. So see here how we can find first IN. So to find the IN, here the question is find the current through 5 ohm resistance. So first we just short the 5 ohm resistance. So then the circuit will becomes, after shorting this 5 ohm resistance, then the circuit is, this is the 10 ohm resistance, and only this should be short circuited. The remaining circuit will be same. You just redraw that one. So this is a 0.1, and here this is the voltage source. So this middle should be short circuited. This 5 ohm resistance should be short circuited. Again 20 ohm resistance, and this is the 0.2 ohm resistance, and here one voltage source is there. So give the values also the same values. What is the voltage source 1? That is the 2 volts. Here this is the 0.1 ohm, and this is the 10 ohms. So here this is the 20 ohms, and this is the 0.2 ohms, and one more voltage source, that is the 4 volts. So after short the 5 ohm resistance, we get a circuit like this. So for this circuit, we just apply the nodal analysis or mesh analysis and find the current. Suppose I am taking the mesh analysis. So here number of loops equal to 2. So in loop 1, just I am assuming the current direction in clockwise I1 and in the loop 2 the current direction is I2, that is in the clockwise direction. So now by applying mesh analysis, you just write the equations for loop 1 and loop 2. So for loop 1 we get 10I1. So it is 10 is linked with loop 1. So 10I1 then minus 2 plus 0.1I1 is equals to 0. So therefore 10I1 plus 0.I1. So what is the value of 10I1 plus 0.I1? That means that is 10.I1 is equals to 2. Therefore, I1 is equals to 2 by 10.1. What is the value of 2 by 10.1? KLC 2 by 10.1. So that equal to 0.198. So that is the current I1. Current I1 is equals to 0.198. So in the same way, you just apply the mesh analysis to the loop 2. Then also we get one more equation. So that is the, you just see. So this is the 20I2. So here 20, this is linked with loop 2. So 20I2 plus 0.2I2 plus 4 is equal to 0. That is 20I2 plus 0.2I2 and next the 20I2 plus 0. Next plus 4 is equals to 0. So by simplifying this equation we get 20I2 plus 0.I2, that is the 20.2I2 is equals to minus 4. Therefore I2 is equals to minus 4 by 20.2. What is the value of minus 4 by 20.2? Minus 4 by 20.2, that is equals to minus 0.198. Minus 0.198. So we get both the currents in loop 1 and loop 2, that is I1 and I2. So here see in the circuit I1 and I2. So we need to find the current through 5 ohm resistance. So here this 5 ohm resistance is linked with loop 1 or loop 2 or with both the loops. So here this 5 ohm resistance is linked with both the loops in loop 1 and loop 2. So when we need to find the current through 5 ohm resistance, so that is only Norton's current. Here Norton's current means that is linked with Norton's current means that is the current through 5 ohm resistance. But here the current through 5 ohm resistance is linked with both loop 1 and loop 2. So here we get I1 and I2. So the Norton's current IN is equals to I1 minus I2. So what is the value of I1 minus I2? So that equal to I1 0.198 minus of minus plus. So that is 0.3960. So that is the Norton's current. Norton's current IN is equals to I1 minus I2, that equals to 0.3960. And this is the first step. In first step we just find the Norton's current, and next in the second step we need to find the value of RThevenin's. So in the same like previous theorem, that is Thevenin's theorem. So in the VThevenin's, how we can find VThevenin's in the Thevenin's theorem? So to find the VThevenin's in the Thevenin's theorem, we just redraw this circuit only, but the only change is in place of voltage source that should be short circuited, and in place of current source that should be open circuited. So after removing we get one circuit that should be same, but only we have to change the voltage source in place of voltage source and in place of current source. So in the same way in Norton's theorem also, so after short the 5 ohm resistance we get one circuit. So we just redraw this circuit again to find RThevenin's, but the only change is Here also in place of voltage source we just replace by short circuit. And suppose if there is any current source in the circuit, in place of that, that is a open circuited. So here see, here in this circuit there is no any current source, there is only two voltage sources is there. So the two voltage sources should be short circuited and the circuit will be same. So we just redraw the same circuit and the voltage sources should be short circuited. So that is the circuit for R So initially this is the 10 ohm resistance, and here one more resistance, that is the 0.1. Again one voltage source is there, that should be short circuited. So middle is already short. This is the 20 ohm resistance, and here one more resistance 0.2. Here one voltage source is there, that is also short circuited. 10 ohm resistance, 0.1 ohm resistance, 20 ohm resistance, 0.2 ohm resistance. Okay, see here. So here we need to find the orthogonal, so equivalent resistance. First, this 10 ohm resistance and 0.1 ohm resistance both are connected in series. So 10 plus 0.1 is equals to 10.1, and here 20 and 0.2, these two are also connected in series. So 20 plus 0.2 is equals to 20.2. So these two are again connected in parallel. So when two resistors are connected in parallel, then what is the formula? So these are connected in parallel. So when two resistors are connected in parallel, then R equivalent is equals to R1 into R1 into R2 by R1 plus R2. So you just substitute the value of R1 is the here 10.1 into R2 is the 20.2 by R1 plus R2, 10.1 plus 20.2. So what is the value of this? By calci. So numerator is 10.1 into 20.2 by 10.1 plus 20.2. So its value is equal to R equivalent, that is equal to 6.733. So that is the R equivalent. So 6.733. So in the first step we just find the Norton's current, and in the second step we just find the value of R equivalent, or it is also called as R Thevenin's. R not R Thevenin's, this is Rn. Small change. This is the Rn, Norton's resistance. Rn. So Norton's current is over, Norton's resistance is also over. So in the start in the start step we just draw the equivalent circuit. We just draw the equivalent circuit. So how can we draw the equivalent circuit? So in the previous class, that is in Thevenin's theorem, we just draw the equivalent circuit. So this is the equivalent circuit in Thevenin's theorem. So how can we draw the equivalent circuit in Thevenin's theorem? According to the statement, the given circuit consisting of any number of voltage sources and resistances that can be replaced by a single voltage source in series with a single resistance connected across the load. So in the same way, according to the statement of Norton's theorem also, we can draw the equivalent circuit. So what is the statement of Norton's theorem? So the Norton's theorem states that in any linear bilateral network, so the given circuit consisting of any number of resistances and voltage sources that can be replaced by a single current source, is connected in parallel with a single resistance, and that is connected across a load. So in the previous class, in the previous theorem, that is Thevenin's theorem, one voltage source that is in series with a single resistance, but in Norton's theorem, that is replaced by a single current source is in parallel with a single resistance. So here this is the Norton's current IN, and this is the Norton's resistance RN, and this is the load resistance RL. So we just take the values of what is IN, what is RN, and what is RL. IN, so in the what we get IN is equals to 0.3960. IN is equals to 0.3960. And what about Rn? Norton's resistance. So Rn is equals to 6.733. 6.733. And what about RL? Already we discussed in the previous theorem. RL is nothing but where we need to find. That is, it should be taken as a RL. So here in the question, they are asking to find the current through 5 ohm resistance. So this 5 ohm resistance is nothing but that is the RL, load resistance. So here RL is equals to 5 ohm resistance. So this is the equivalent circuit. So after drawing the equivalent circuit, we just find the total current IL. So here also one formula. In the previous theorem, in Thevenin's theorem, what is the formula to find the load current? So IL is equals to V Thevenin's by R Thevenin's plus RL. That is for Thevenin's theorem. But here this is the Norton's theorem. So for Norton's theorem, the formula is IN into RN by RN plus RL, where IN is the Norton's current, RN is the Norton's resistance, and RL is the load resistance. We are already know all these values. So what about IN? IN is already we are getting, that is 0.3960. 0.3960 into Rn. What about Rn? That is 6.733 by again Rn. What is Rn? 6.733 plus RL. What about RL? RL is the y. Again, what is the value by using calc? So first is the 0.3960 into 6.733 by 6.733 plus 5. So that is equal to 0.227. So this is a total current which is passing through 5 ohm resistance in the question. So find the current through 5 ohm resistance by applying Norton's theorem. So finally we get the answer, that is the current flowing through 5 ohm resistance is equals to 0.227. So this is the Norton's theorem, and this is the procedure to apply the Norton's theorem. In Norton's theorem, we just find the Norton's current first, and next Norton's resistance, and then draw the equivalent circuit, and finally current through that particular resistance by using a formula IL is equals to IN into RN by RN plus RL. Okay, this clear? Okay, thank you. So by this we completed all the three theorems, that is superposition theorem, Thevenin's theorem, and Norton's theorem also. So in the next class we discuss one more problem, one more topic.